We're going to graph these polynomial functions quickly using three things: the degree, the leading coefficient, and the constant term. Let's piece these together. So first off, degree determines the shape. Second thing is leading coefficient. The leading coefficient will determine if I'm going to end like the typical graph or if I'm going to be a reflection. So leading coefficient determines reflection. And last, we're looking for a constant term, just to have at least 1 point on the graph. The constant term, meaning the number without a variable, the constant term is our y-intercept. Because if we plugged in a 0 for x, we would get that constant term. We symbolize the constant term as a with a subscript of 0. Now let's talk about degree determines the shape. If your degree is even, so even degree kind of looks like a parabola where I'm either shaped like this or I could be a reflection of that. If you have an odd degree, that's where the disco comes in, where kind of looking like an S. The higher the degree, the more of an S you look like. So like x to the 5th looks more edgy than x to the 1st power. Leading coefficient determines reflection. So if you have an even degree, but your leading coefficient is negative, it's a reflection flipped down. If you have an odd degree, but your leading coefficient is negative, then that means you have a reflection, the S is flipped. Constant term at least gives us a point to have. Let's figure out, okay, what is our degree so we can determine the shape? Degree of the polynomial is the highest exponent. So it's a 3. So it's going to be an odd shape. Then I go to the leading coefficient. Leading coefficient is what in this case? It's a positive 1. So wait a second. I have an odd degree and it's positive. So wait, if it's positive, then it's just going to look like the typical down to up kind of graph. So leading coefficient's positive 1, no reflection. And last, we need to determine what our constant term is. Do we even have one? Our y-intercept is when you plug a 0 into x and it spits out your constant term. You can always do the math, like put in 0. What's 0 cubed minus 2? Just left with negative 2. So we're going to graph the point 0, negative 2. We're ready to sketch. Here's what I mean by sketching. Let's put an x-axis, a y-axis. We're going to graph the constant, or the y-intercept, at 0, negative 2. And then we're going to create kind of an S curve, like what we saw during that study guide time. And it's just going to pass through. It's a rough sketch. Let's discuss end behavior. End behavior is not as bad as what we're thinking, because it's still like, we still put as x goes to negative infinity, meaning as we move left, and we're also going to discuss as x approaches positive infinity. We still discuss both ways. As x goes to negative infinity, as we move left, how would you describe this arrow? It's going down. So let's think about how we're going to symbolize that. We're no longer going to do y is approaching. We're now going to use function notation. F of x approaches negative infinity. And then to symbolize, wait a second, as we go to the right, this arrow is going up. So instead of y, I'm going to put f of x goes up. That's how I symbolize it. F of x approaches positive infinity. Next polynomial, we're going to determine degree, leading coefficient, constant term, and then discuss end behavior. So, our criteria, we look for the degree. Degree of this polynomial, yeah, the only exponent I even see, but it's 4. So degree is 4, that determines the shape. It's even. When it's even, it's like a parabola. So we're looking at a U shape. The higher the exponent is as you get even, the more edgy you look. A parabola is kind of nice and smooth. And as you get x to the 4th, it starts kind of getting squattier. Should I say that? Almost starting to look like a touchdown. So, as your power increases, being even, like x to the 10th, it starts getting more touchdowny. Okay, leading coefficient determines whether or not I'm going to have a reflection of that. So, leading coefficient is -1. So it's no longer looking like a regular parabola, it's a reflection. The constant term will give me my y-intercept. Wait a second, do I have a constant term? Notice how I don't have a number out here that has no variable. So I would assume it's 0. Wait a second, let's test it. If you plug a 0 into the x and take 0 to the 4th and then take the opposite of that, you're still at 0. So there's always the way to test it if you don't remember this constant idea. So, y-intercept is 0, 0. End behavior, can we describe this? The left arrow is supposed to be down. So as x approaches negative infinity, as we move left, f of x should be going down, negative infinity. As we move right, or as x approaches positive infinity, f of x approaches, wait a second, as we go to the right arrow, it's going down. So to represent that, f of x is approaching negative infinity. Let's draw a sketch. Sketch of this. I have a y-intercept at 0, 0, and I'm supposed to be looking like I'm going down. So what we're going to do is we have a left arrow and the right arrow going down. So we map out everything that we need in order to graph this. You identify what the degree is. I threw all of these up here to figure out, okay, where's the degree? Or which is the degree? It's the highest exponent. So the degree is 3. And the most important thing here is to recognize that that is odd. It's an odd number. So I figure out, wait, it's supposed to be that S curve. It's supposed to look something like that. Then the leading coefficient will let me know if it's supposed to be a reflection. Leading coefficient, -1. So now I'm no longer moving like that. I'm going to switch direction. I'm going to go up to down because I read this left to right. Up to down. Constant term will help me figure out what my y-intercept is. Do I have a constant term? Again, I don't have a number without a variable. If you plugged in 0 into this function, you would still get 0 as the output. So the y-intercept, 0, 0. End behavior. So looking at the left arrow, left arrow, I'm up. So that means my output, or my f of x, should be going to positive infinity. My right arrow is down. So f of x will be approaching negative infinity. We really got to get fluent with how to represent an up arrow and how to represent a down arrow. We're ready for the sketch. You plot the constant, or you plot the y-intercept, and then we're going to have a curve. As we get further along this chapter, we're going to figure out, wait a second, are there any x-intercepts I need to worry about? Because in this graph, actually, there's not just one x-intercept, but there's 3. Bum, bum, bum. So that's where we're going to get to starting this chapter. So how to figure out the x-intercepts in these graphs. For tonight's homework, this is all I want you to practice. Find the degree, find the leading coefficient, find the constant term, identify the end behavior, and sketch. Here's your homework. It's listed on that schedule that I passed out yesterday.